Now that we have a basic understanding of sensitivity and specificity, let's go ahead and look back at our Down syndrome example. Now, in the very second video we looked at, we saw that in reality, if you got a positive test result, there was only like a 3% chance that your baby was going to have Down syndrome, which looked like in reality we might be causing more harm than it's worth in telling a bunch of women their babies might have Down syndrome when they're not actually born with it. So the question is, how accurate is this test actually? And to do that, let's go ahead and look at sensitivity and specificity for it. Now, in reality, we've already calculated sensitivity, even if we didn't call it that. Sensitivity measures if we have the condition, that is, if we have Down syndrome, what are the chances the test tells us that? That is, what are the chances we have a positive? To find this, we consider the fact that it's a conditional probability. There were 54 women who had a baby with Down syndrome. Out of those 54, 48 had a positive test result, which gives us 0.8889 or 88.89%. So what we're saying here is if your baby is going to be born with Down syndrome, there's an 88.89% chance the test will flag that, tell you it's going to happen. Now, once we've looked at sensitivity, let's go ahead and look at specificity. Now, specificity measures the chances if your baby is going to be born without the condition. I'm going to write that as Down syndrome complement. What are the chances that you get a negative test result? That is, the test accurately reflects that. To calculate this, we need to go ahead and put the total number born without Down syndrome, 5228 on the bottom, and on the top, the number who got a negative, 3921. What this allows us to do then is go ahead and divide, and when we do that, we'll get 0.75 or 75%. This is kind of interesting to look at, and what it tells us is that we have a higher sensitivity than specificity. This means we're being more accurate at telling women their babies are going to have Down syndrome than telling women that their babies will not have Down syndrome. In trying to be extremely accurate in telling people their babies are going to be having Down syndrome, we're actually telling too many women this result. And because we're telling too many women that their babies are born with Down syndrome, that means our accuracy in detecting negatives is decreasing. In reality, neither of these numbers are exceptionally high, which raises the question, like, why are we giving the triple blood test? If we're not that good at telling women their babies are going to have Down syndrome, and we're really bad at telling women their babies won't have Down syndrome, why is the test even given out? And the answer for that actually has to do with the age group we're administering this to. The idea with the triple blood test is kind of twofold. One, it's the earliest test we can give women, so if they want results really early in their pregnancy, this is the way to give it to them. The other reason for it actually has to do with this column right here. That is the negatives. In our group of women over the age of 30, there's an increased risk, according to research that was done quite a while ago. Newer research is still evolving with it. But according to older research, women over the age of 30 have an increased risk of having a baby born with Downs. The nice thing about this test is it tells us if you have a negative test result, the chances your baby is actually born with Down syndrome is super low. That is, out of the 3,927 women who got a negative, only 6 had a child with Down. This is 0.0015, or 0.15%. That is, if you go in and you get a negative on this test, you can rest pretty assured that your baby will be born unaffected by Down syndrome. This is one of the primary reasons this test is actually given. Now, once again, there are other reasons I want to reinforce that, such as it being a really early test that can be given early on in the pregnancy, but this reassurance is definitely a positive for it.